Hi everyone, I'm Euan Morris, and this is a virtual presentation for the paper Evolution of Electricity Distribution Control Room Data Streams, UK Case Study. I'm going to start off by detailing the challenges and opportunities that motivated this work. As the UK, along with much of the world, moves towards net zero, network operators will operate in a more complex, rapidly changing environment while interacting with a broader range of network participants. Networks will have to offer resilience to unforeseen events, such as threats from weather, which are only set to increase, and will have to manage growth in new technologies such as active network management schemes and ever more advanced network automation and control schemes, which require a major change in control system design and operational practice. For example, a shift in the balance between centralized and decentralized control. More flexibility services will require network operators to monitor and mitigate increasingly complex and variable power flows. And control room operators themselves have to process and act on growing data volumes, which present an opportunity to improve network visibility and support informed future operation. The project objectives were to identify a range of existing and new use cases for the future control room, create a set of future scenarios and perform a first assessment on how today's control room will need to be adapted, and capture the current and future functionalities and requirements of technology vendors and suppliers. The activities we undertook in the project were stakeholder engagement with network operators themselves through workshops, requirements gathering using the literature and other publications by network operators, and an assessment of market conditions and existing and planned technologies. We then performed a series of analyses, a data streams assessment, an assessment of the potential AI and ML functionalities, and an assessment of the interfaces and interoperability of these data streams and functionalities. We also created a functional architecture and architectural specification, which is not covered in this presentation, but is covered in a concept solution architecture for electrical distribution control centers, which is also available at this conference. So we're going to start off by looking at the data streams that exist within the current distribution network operator control room. The heart of these data streams is the distribution management system, which is interfaced with the SCADA system, which is the supervisory control and data acquisition system. So this is how the control engineers receive data about the network and how they action control actions as well. So the SCADA interfaces with RTUs, which are the remote telemetry units, which are the monitoring on the low voltage network. And they also interface in certain circumstances with the active network management system if there's one for that network. The DMS also interfaces with outage and customer management, which is how the network operators inform customers of outages and how customers can report outages to their network operator. It interfaces as well with the GIS, the Geographic Information System, which provides information about the location of assets as well as information about their ratings and functionality. This interfaces with field operations, so people going into the field to perform maintenance or inspections and feed that information back as well to the DMS. Historical data from the DMS is stored in the data historian, and that can inform future planning as well as data analysis, which is also informed by the GIS system. So that's an overview of how the data streams work in the current control room. Looking at the results of the stakeholder analysis, we were able to divide these into 5 categories and then 3 cross-cutting themes that there are elements of in each of those categories. So the first was flexibility and ancillary services, which was effectively the facilitation of a flexibility market with economic and efficient dispatch of distributed energy resources that reduces the impact of outages, improves system balancing and coordination, and can incorporate peer-to-peer energy trading. The second was network stability and security, so improving the stability of the network, increased interconnections, storm and extreme event management, multi-utility black start, including from distributed energy resources, and intra-control room reliance. Internal control system interactions, so a control operator-focused human-machine interface, a simple single view of real-time information, a training simulator, an open architecture, and distributed access and remote working. External control system interactions, so active communication with customers, real-time updates on faults, resilient communication with field staff, and to send and respond to data signals from third parties. And data analytics tools, tools for the analysis of multiple data sets that can handle large volumes of data, can incorporate plug-and-play new software tools and updates, and that combine a speed of response with complex data provision. The cross-cutting themes were monitoring, so for flexibility services, visibility of the assets and the state of the current market. For network stability, monitoring of inertia, fault recognition, load flow and thermal analysis, and active network management. For internal control system interactions, low voltage network visibility, a display of planned and unplanned outages. For external control system interactions, real-time location of operatives in the field and reliable data signals to and from the field. And for data analytics tools, real-time impact of network decisions and an overview of conflicts between goals. Forecasting, so again for flexibility services, forecasting the market, forecasting the impact of control actions. For network stability, forecasting the generation and load on the network, forecasting the impact of weather, and simulation of different weather scenarios. For the internal control system interactions, the predicted impact of control actions on the network, on carbon emissions, and on vulnerable customers. For external control system interactions, an accurate estimation of fault restoration time. And for data analytics tools, the commercial implications of network decisions. And the final cross-cutting theme was automation. So decision support for flexibility decisions, decision support for network stability and outage management decisions, explainable AI for supporting restoration and for fault recognition, automated provision of relevant information to affected customers, and lastly, the ability for data analytics tools to self-configure as new data sources are added. So, how would this impact the data streams that we've already looked at? Well, this again is the data streams for the existing control room. One of the first changes that would be required is a secondary SCADA system and additional low voltage monitoring. A second change would be interfaces with third parties. So this might be gas networks, this might be other distribution network operators, this might be weather services. There is a complex series of data streams from the incorporation of smart meters. And for privacy reasons in the UK, smart meter data has to go through a gateway and then be aggregated before it can be used for planning and for operational purposes. But one thing that can happen is alarms for when smart meters detect a loss of supply, and these can go straight into the DSM alongside the existing management system. And the other big change that was discussed is the flexibility market. So that would come in through flexibility aggregators, through a flexi services gateway, and then would have to be settled both in terms of control actions and as a financial settlement as well. So, in conclusion, control room data streams are set to become significantly more complex, needing to cope with smart meter data, flexibility markets, interconnection between energy systems, and new third-party data sources, including weather services. The current control room setup may be expanded to cope with this, but without smarter tools and approaches, control room engineers may be overwhelmed. And a proposal to partially deal with this is covered in our paper. Thank you all very much for listening.